Welcome to Pomodoro Joe for Saturday, July 15th, 2023. Today we're doing LeetCode problem 1751. Maximum number of events that can be attended, 2. This is a hard problem. You are given an array of events where events index I is equal to the start day, the end day, and the value. The ith event starts at start day and ends at end day. And if you attend this event, you will receive a value of value. You are also given an integer k, which represents the maximum number of events you can attend. You can only attend one event at a time. If you choose to attend an event, you must attend the entire event. Note that the end day is inclusive. That is, you cannot attend two events where one of them starts and the other ends on the same day. Return the maximum sum of values that you can receive by attending events. All right, and then they have some examples. So here's one example. So it starts on day 1, ends on day 2, and you get 4 points. The next event starts on day 3, ends on day 4, and you get 3 points. And the third event starts on day 2, ends on day 3, and you get 1 point. So it looks like we can do 1 to 2, but then we can't do this 2 to 3. But we can do 1 to 2, and then 3 to 4 to get 7 points. That's k of 2, and yep, output is 7. Cool. A couple more examples, and then some constraints. All right, I think this is pretty straightforward, so we'll put 25 minutes on the Pomodoro timer, and we will get started. So we'll start with some result, set it equal to 0, and we will return the result at the end. Now what I want to do is reduce this problem basically one step at a time. So we have this k, which means that I can probably do a recursive solution where we reduce that k one at a time. So my plan here would just be to select an event, get the points for that event, and then recurse on the remaining events with k minus 1. Go through until we reach no more events that we can attend, and then add up all those points. All right, so first, let's make our recursive function here. We'll call it max value recurse. All right, now for this, I can either take a new list of events and a new k, or I can take an index of my starting index for the event and the remaining k. So I think I'll do that. I'll have my start index and my remaining k. Now one reason I do this is so I don't have to make copies of these lists of events when I pass them down through these recursive calls. The other reason I do it is because these are two integers, that means I can cache this input. Basically, I can use dynamic programming to cache these inputs and their output, and that will save me a ton of processing later on. All right, so let's see. First, I'll do my base cases. Since this will be my recursive function, I'll start with a base case. So if the start index is greater than some max index, that means we are out of bounds. We have to return 0. All right, so let's see. I'll need this max index. Let's create that out here. Now the max index is just the length of my events, or yes, my events, minus 1. All right, what else do we have to do? Well, if we don't have any more events we can attend, if the remaining k is 0, then we also have to return 0. I could probably just do that here. All right, so these are my base cases. If the start event index is out of bounds, or if we have no more events we're allowed to attend, we return 0. All right, so then what's next? Well, at this point, it's fairly straightforward. We go through every event, and for each event, we can either attend the event or we don't attend the event. Those are our two options. So in the end, we'll have this set of events that gives us the maximum value, and either this event is in that set or it's not. So basically, we either attend this event or we don't. So the simple one is, let's not attend the event. So don't attend. So if we don't attend the event, then this is just a recursive call. So I'll call this option 1. So we'll do our recursive call. And we'll just pass in the start index plus 1. So we'll go on to the next event. We're just not going to do this event. And our remaining k stays the same because we didn't attend any events here. We're skipping this event. We don't have to reduce our k. We just move on to the next event. So that's the easy case. What's the more difficult case? That's option 2. This is where we attend the event. I'll call this option 2. So with option 2, we'll attend this event, which means we'll lock in the points for this event. Let's see, let me actually grab the event here. All right, so I grabbed the event. Now I'll lock in the points for this event. That's event index, what is that? 0, 1, 2. Lock in the points for this event, plus the points that we can get for recursing. Let's try that. So we still go to start index plus 1 and remaining k minus 1. All right, and then we return whichever gives us the better result. So the max of option 1 or option 2. All right. Now, there are a couple things I haven't covered yet, so we'll get back to those in just a second. So first, we haven't actually called this for the first time. So out here, our result will be this max recurse with an index of 0. We're going to start at index 0, and we will have k events. Okay, so we have our initial call. All right, so the things I haven't covered in here are, what about conflicting events? So in this case, I'm just saying we either attend the event or we don't. But what if we attend an event and then the next event, this index plus 1, actually conflicts in our days with the first event that we just attended? So we have to actually make sure that this event doesn't conflict with any future events that we try to attend. So in order to solve that problem, there are a couple different things we could do. One is we can just go through all of the events, check the start and end times, see if there's a conflict, and create a new set of events. But if we ever create a new set of events, then our start index is all thrown off. We don't have really the index for this new list of events. So I really don't want my events that I'm iterating through to change as we're going through them. So we need to find a better way to solve this problem of finding conflicting events. So one thing we can do is we know that each event has a start and end date. We can just sort all of our events by their start or end dates. I think if I sort by start date, so I can sort all my events by their start date, then I can check to see what's the next event in my events list that doesn't conflict with this event by just checking to see if that event has a start date that's after my current event's end date. So let's do this. Let's sort our events. Now let's see, if I just call the default sorted, that will sort by the first value first, the second value second, and the third value third. That actually works out for us. So the start day is what we want to sort by. So it'll sort by start day first, then end day, then value. That's perfect. We don't need to do anything different. All right, but that does mean that our sorted events is the thing we want to grab our event out of. All right. And now we can't just start at the start index plus 1 anymore, because that could conflict. We actually need to find an event that doesn't conflict with this event. So this won't be start index. This will be something like next index. So let's do that. All right, so what is our next index? Well, we can start it as the start index plus 1. So we can definitely move on to the next event. But now we need to find the actual next index, and that's going to be the event that doesn't conflict with our current event. So let's see. Let's try this. So while the next index is less than our max index here, we don't want to go out of bounds. And let's see, it's going to be our sorted event. So we'll just grab the event at this next index. So if the sorted events, let's see, we need to check to see this sorted event, our next event that we're looking at, its start date has to start after our current event's end date. So its start date is at index 0, and this has to be greater than our current event's end date, which is index 1. All right, so that's what we're looking for. So I guess what I want to say here, we'll be advancing our next index. So we just keep looking at the next index to see if we can find an event that fits our criteria. So our sorted event, this next event that we'll be attending, its start time or start day has to come after our event's end date. So while I'm less than or equal to our event's end date, then I'll keep updating this index. All right, and I think I can actually go all the way up to my max index here because I do want to be able to look at this last event. All right, so I think that should cover that. This is looking pretty good. This actually might be it. All right, let's take a look at this. So we have our recursive function. We'll call it at the beginning with just 0 and k as our remaining k. Then we have our base cases. If we are out of bounds, or if we don't have any events left, if our remaining k is 0, then we return 0. Otherwise, we just have two options. Option 1, let's not attend this event. We'll just move on to the next event. So that's going to be our recursive call with index +1, and remaining k doesn't change. The other option is we do attend this event. So let's just grab this event and make sure that we get its points and its end date out of there. So we'll grab this event. We'll find the next possible event we can attend by going through our list of remaining events, looking for the first event whose start date happens after our current event's end date. Once we find that, then our option 2 is we lock in the points for this event, and then we recurse on the next set of events that we can attend. And then we just return the maximum of our option 1 or option 2. So let's give this a shot. Okay, so this works. Now let's see if we can pass all the tests. Now one thing I'm not doing here, I'm not doing any DP or caching, so this probably won't pass, but let's see how we do. And just as I suspected, we don't pass. We have a time limit exceeded, but we actually do much better than I expected. We beat 64 out of the 67 test cases. So we'll grab this test case, and we can either do dynamic programming or we can use caching. Let's start with dynamic programming so I can just show you how to do it, and then we'll go to caching later. So for dynamic programming, this is pretty straightforward. We have a DP, that's just a dictionary. So we have some dictionary. Now here, first thing we do is we create our key. Now the key is just going to be the combination of our inputs. That's the start index and the remaining k. So for this, we can just use a tuple with start index and remaining k. All right. So this is the key. Now, if this key is in our DP, so if we've already had an entry for this key, then we will return that value. So DP for this key. That means we don't have to do any of this processing. We've already stored this value and we can return it. Otherwise, we just have to find all of our returns. So we have one return here. So for this, we need to set the DP for this key equal to 0. And then down here, we actually have to set the DP for this key equal to this max value. And then we can return the DP for this key. So the simple way to do DP is create a dictionary, then grab your key at the beginning. If the key is just going to be your inputs, check to see if you have that key in the dictionary, and if you do, you can just return it. Otherwise, you just find all your returns, and any place you had a return, you'll replace that with a DP key equals whatever you were returning, and then you return the DP for the key. All right, let's try this. All right, so now we passed that one test case we weren't passing before. Let's see if we can pass all the tests. And we pass. Let's see, and we do okay. We beat 61% for runtime and looks like 35% for memory. So that's not too bad. Let's jump back here. Instead of doing this DP, let's get rid of all this and let's just use our caching. So Python has a built-in type of dynamic programming. It's also like memoization is another term for this one. So basically we can use this decorator @cache. So it will do the same thing that our DP did, but it will just do it more efficiently because it's a built-in function. All right, and down here we still need to return this. Okay, so now we're back to our original solution. The only difference is we're adding this cache. Let's see if this will pass all the tests. All right, see how we do. And we do better. Now we're at 79% for runtime and 31% for memory. So yeah, not too bad. Now let's jump back and do one last thing. I do like having my own max calculations because they do tend to work a little bit better. So we'll return option 1 if option 1 is greater than option 2. Otherwise, we'll return option 2. This is our own version of a maximum calculation. All right. Awesome. Now we're up to 84% for runtime and 28% for memory. So yeah, keep inching a little bit closer to that 90%. I bet if we went in here and changed some of these names, we could get above 90%. But I think I'm pretty satisfied with the solution. All right, again, for this one, we have the basic solution, which is just for every event, we either do the event or we don't do the event. From there, it was just a matter of sort of maximizing how we go through all the remaining events. And for that, we just did a sorted array and choose the events that only happen after our current event ends. Okay, well, I think that's it for me. Hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.